This is the first video on the binomial expansion, where I'm going to show you what it is, what the formula is, and how to do a couple of simple examples. So you've already actually done a couple of binomial expansions in GCSE. All a binomial expansion is the bi means two, the nomial means terms, basically. So two terms, expanding that. So you've already done something like that, a plus b all squared. You've expanded two terms. A plus b all cubed, you've expanded that as well. So you've done that in GCSE the long way by multiplying out all the brackets, which is fine. The problem is when you then get to a higher power, if it's a power 4 or power 5, this method here doesn't really work anymore. Well, it works, but it's just too long and too messy. So we want a shorter way of doing it. That's where the binomial expansion comes in. So this is the binomial expansion. It's what you're given on the formula sheet. It's not how I remember it though. The way I remember it is like this. So I remember each term, each part of the expansion will look like this. It will be NC something, A to the power something, B to the power something. So you have a coefficient, the A term to some power, the B term to another power, and so on. The way that the powers work, well, that will always be an N there at the front. It will always be NC something. At the beginning, we start with a 0 there, and then it goes up. So it will be an NC1 here. The term after that would be an NC2. The term after that would be NC3, and so on. All the way up to where you get to NCN. The A starts off as being power N, and then goes down. So this number here will go down each time. And this number here will go up each time. So let's have a look at an example where this will become a little bit clearer and you'll hopefully spot the pattern and you won't need to worry too much about this. One of the things, the NCR, I'll talk more about what that means in detail in the video 2 where I explain where this formula comes from. But basically all NCR means is how many different ways are there of you choosing R objects from N. And the calculator, you've got a button on your calculator that can do this for you. So all you need to do is just there above the divide. All you need to do is to press the shift and the divide to get it. So if I want to work out how many ways there are me picking 3 objects from 10, all I would do is I'd type 10, shift, divide, 3, equals, and that'll tell me. Anyway, let's look at an example that will hopefully make this a little bit clearer. So I want to find the first 3 terms in ascending powers of x of the expansion of 3 minus 2x to the power 6. So in this case, my power n is 6. So I'm going to start off 6c0. The first term will be to the power 6. The second term will be to the power 0. Hopefully you can see that's the same thing here. 6c0, a to the power 6, b to the power 0. 6c0, the first term to the power 6, the second term to the power 0. Plus, well, I'm going to write out exactly the same thing. These two numbers go up, that goes down. 6c1, 3 to the power 5, minus 2x to the power 1. I'm going to write out exactly the same thing. These two powers go up, that power goes down. Okay, that's it. That's how the binomial expansion works. All we need to do now is just to simplify this. So, 6c0, and let's say you can type that into your calculator. You can go 6, shift, divide, 0 equals. You will get 1. In actual fact, that's always going to be the case. That's always going to be a 1 at the front there, because how many different ways are there of me selecting 0 objects from 6? Well, 1. There's only one way of me picking none of them. Anyway, so 6c0, it's just 1. Multiplied by 3 to the power 6, which I think is 729. Multiplied by minus 2 to the minus 2x to the power 1, 0, sorry. Anything to the power 0 is 1. So that's going to be a 1. Plus 6c0, so if you type in 6, shift, divide 1, press equals, you'll get 6. 3 to the power 5 is 243, minus 2x to the power 1 will be minus 2x. 6c2, so type in 6 shift divide 2 equals, and I think you get 15. 3 to the power 4 is 81, minus 2x all squared, so the whole thing is squared, so the minus 2 will become a 4, and the x will become an x squared. Okay, all we need to do now is just simplify this a little bit more. So obviously 1 times 729 times 1 is 729. The 6 times 243 times 2, or rather minus 2, so this whole term here is going to be minus, because of the minus there, and the 6 times 243 times 2 is going to be 2,916x. And the term over here, 15 times 81 times 4, is going to be 4,860x squared. And there we go. Those are the first 3 terms of expanding that binomial. Right, let's do one other example where we are going to do the full expansion now. So notice it's not said the first 3 terms, it just says expand it all. So you could do it the long way you learned in GCSE, but let's use the binomials in a quick way. The power is 4, so 4c0, the first term to the power 4, the second term, which is y squared, to the power 0, plus 4c1, the first term to the power 3, the second term to the power 1, plus 4c2, the first term to the power 2, the second term to the power 2, plus 4c3, the first term to the power 1, the second term to the power 3, and finally 4c4, the first term to the power 0, the second term to the power 4. You know when to stop because you get to the 4c4. Okay, so those are all the terms of that expansion. Let's figure this out. So 4c0, I know that that is 1. 2 to the power 4 is 16. Y squared to the power 0 is going to be just 1. 4c1, I know that that is going to be 4. Type that into a calculator. 4 shift divide, and then that's 1 equals 2 cubed is 8, y squared to the power 1 is y squared. 4c2, type that into your calculator, you'll get 6, times 2 squared, which is 4, times y squared, squared, so when I square y squared, I get y to the power 4. 4c3 is 4, 2 to the power 1, times y squared cubed is y to the power 6. Plus 4c4 is 1, 2 to the power 0 is 1, y squared to the power 4 is y to the power 8. And now we can simplify all of this. So this is just 16, this is 32y squared, this is going to be 24y to the power 4, plus 8 y to the power 6, plus y to the power 8. And there we go. So we've expanded that completely then. In the last video I talked about the binomial expansion. I talked a lot about this NCR notation, using the calculator to do it. However, if we don't know what the power is, there's nothing I can type into the calculator to help me. So we need another way of dealing with this NCR. That's where this comes in. This is actually what the calculator does. When you type in NCR into the calculator, this is the calculation that the calculator does to return the number. So this is the more important thing, really. In the second video, I'll actually show you where this formula comes from. But for now, I just want to explain what the factorial notation means and how you can use this to expand a binomial. So, factorial notation. It's this exclamation mark. That's what we mean by factorial notation, or that is the notation rather. And what it means is, if I said 4 factorial, all that means is 4 times 3 times 2 times 1. So you start at that number and you multiply all of the integers below it down to 1. So in this case here, 4 factorial is 24. Yeah. If I said 3 factorial, that would just simply be 3 times 2 times 1, which is 6. That's all the factorial notation means. A couple of points to say here. Factorials often divide very nicely. If I've got, say, 10 factorial over 8 factorial, now 10 factorial is 10 times 9 times 8 times 7. That's 10 factorial. I'm not going to work all of that out, because when I divide it by 8 factorial, I'll get 8 times 7 times 6. And then what do we notice? Well, actually, all of this cancels with all of this. And I actually just get left with 10 times 9, which is 90. So this is 90. So factorials simplify really nicely. That's going to be useful for us in a minute. The other thing I want to say is in terms of algebra, if I said n factorial, what does that mean? Well, it means I start at n, and I multiply that by the number one less than that, and I multiply that by the number 1 less than that, and the number 1 less than that, and so on, until I get down to 1. That's what n factorial means. So that'll be useful for us in a moment. Okay, so let's look at an example. I want to write down the first 3 terms of 2 plus x to the power n in their simplest form in terms of x and n. And I'm going to use this notation. So first of all, let's just write out the binomial expansion like we did in the first video for this. The first term would be nc0, 2 to the power n, x to the power 0. Okay? Remember, we start off nc0, the first term to the power n, the second term to the power 0. Then the second term, this goes up by 1, this goes down by 1, so that's an n minus 1 now, and the second term power goes up by 1. So these two go up, that goes down. And then the third term, nc2, 2 to the power n minus 2, x squared. So again, these two have gone up, that's gone down. Right, let's try and simplify this. So nc0, we saw in the last video, that's always going to be 1. Yeah. There's only one way of picking 0 objects from however many objects there are. So this is always going to be 1 here. And we could use the formula to show that. 2 to the power n multiplied by x to the power 0, which is 1. Right, more importantly, let's start figuring out what these terms will be. So I'm not going to simplify this too much at the moment. I'm just going to focus on the nc1 and the nc2. Let me use a different colour for this. So nc1, using this notation, I would write n factorial over, so r is 1 in this case, so over 1 factorial multiplied by n minus 1 factorial. So I've just copied this down and just using r as 1. I'm now going to write out what these factorials mean. So n factorial means n multiplied by n minus 1 multiplied by n minus 2, multiplied by n minus 3, and so on. One factorial is just 1. Then I've got n minus 1 factorial. So that's n minus 1 multiplied by n minus 2, multiplied by n minus 3, and so on. Okay? Start off at n minus 1, then you multiply by the number that's 1 less than that, so n minus 2, n minus 3, and so on. And what you should hopefully notice is we get a lot of cancellation, like usual with these factorials. Whenever we divide a factorial, we get lots of simplification. And actually all I get left with is just n over 1, which is n. So this nc1 will simplify just to be n. So I can replace that with an n. I'm going to leave the 2 to the power n minus 1 like it is for the moment, and let's leave the x there. We'll deal with those terms in a minute in terms of simplifying. Let's look at the nc2. Well, nc2, that would be n factorial over 2 factorial multiplied by n minus 2 factorial. So again, just using this, but with r as 2 now. N factorial means n times n minus 1 times n minus 2 times n minus 3, and so on. 2 factorial means 2 times 1, which is 2. The n minus 2 factorial means n minus 2 multiplied by n minus 3 multiplied by n minus 4, and so on. And again, we can see we've got some cancellation here. The n minus 2's cancel, the n minus 3's cancel. The n minus 4 here would cancel with the n minus 4 here that I didn't have space to write down. All of those are going to cancel and just leave you with the n times n minus 1 over 2. So instead of writing nc2, I can write n minus 1 all over 2, and then these other terms. Right, let's simplify this as much as we can now. This first term here obviously simplifies very easily to be 2 to the power n. Right, the 2 to the power n minus 1, how could we simplify that? Well, we know from GCSE that we could use index laws to rewrite this as 2 to the power n multiplied by 2 to the power minus 1. Which is the same thing as saying 2 to the power n multiplied by a half. Or 2 to the power n over 2. So I can replace 2 to the power n minus 1 with 2n over 2. So we've got the n in front. Here we've got 2 to the power n over 2 multiplied by x to the power 1, which is x. Here we've got the n minus 1 over 2 multiplied by the 2 to the power n minus 2. I can rewrite that in a similar way as 2 to the power n times 2 to the power minus 2, which is the same thing as 2 to the power n times a quarter, because 2 to the power minus 2 is 1 quarter, or 2 to the power n over 4. So I can write that and then the x squared on the end. Okay, final step. I'm going to simplify this as much as possible. I can see that I've got a 2 to the power n in all of these terms, so I can factorise that out. So here I'll just be left with n over 2x, because I factorised the 2 to the power n out. I'm allowed to factorise the 2 to the power n outside, because I know that I will always have a 2 to the power n. In every term of this expansion, I will have a 2 to the power n at the front. Just here it gets divided by 2, here it gets divided by 4, the next one would be divided by 8, and so on. So I know I'm always going to have a 2 to the power n in every term, so I'm allowed to factorise it out. So yes, here I'm left with the n over 2 times x. Here I will be left with the n times n minus 1 over 2 times 4, which is 8, x squared, and so on. There we go. So that is my expansion. I don't think I can simplify it any more than that, really. Those are the first 3 terms of that expansion in terms of x and n, like that. And that's how we can use this notation to help us to expand a binomial if we don't know what the power is. If the power is an unknown, we can do this notation. If we do know what the power is, you can do what we did in the previous video and just use the calculator, which will be the majority of cases. But if we don't know the power, this is the way to do it.